see the definition of the pointer, then we will justify the definition of the pointer in terms of like programming. So the definition of the pointer is like this, that is, pointer is a variable that stores the address of the another variable of similar data type. So first we will discuss the first part of the definition, that is, pointer is a variable that stores the address of another variable. Then later in the next video we will discuss about, like, why it should be of the similar data type. Why it can't hold the pointer cannot hold the address of a variable which belongs to the another data type. Why this is being traced? Because every pointer variable will be the size of the integer data type. That is, if I take that one on a 16-bit processor, then the size of the integer is 2 bytes. So even the pointer variable will be of the 2 bytes. So even the float pointer will be 2 bytes, character pointer will be 2 bytes. So whatever might be the data type it might be, it will be the size will be the 2 bytes. So now the question is, like, then why can't an integer variable address cannot be stored inside a float point variable? We will see that one in the later part of the video. But first we will discuss about the pointer, that is what do you mean by a pointer, and how exactly that we are going to store the address. So let's get started here. So here in the main, I have taken two variables a and b, and I have taken a pointer variable. This is how we will be representing the pointer. That is, before the variable, if I put the asterisk symbol, that becomes a pointer. Now this variable is capable of holding the address of the variable of the similar data type. Okay, so here I have stored the address of the variable a into the pointer variable p. So whenever we wanted to store the address, we are supposed to place this ampersand symbol. Ampersand symbol indicates the address of this particular variable that we are trying to store inside this particular variable called as p. So this one, let us see how this will be stored on the RAM in order to get more clear about how exactly we are storing on the RAM. Right, this is the RAM structure. So the RAM structure where it will be having the equal slots, and each and every slot will be having the addressing, and the processes which are invoked currently, that will be placed on the RAM. Now in fact, the lower part of the RAM will be always occupied by the operating system. Okay, however, now let us see about the RAM structure that we have used here for our program. Here you can find whatever the variable a, there we have seen, I wanted to store that particular variable a in the address locations of the 201 and 202. That is assuming that the processor is a 16-bit processor where it requires 2 bytes of the memory. Now, will it going to store exactly a equals to 10? That is, even the variable a will be stored in that particular 2 bytes of the memory? No, that is the constant which will be held by that particular variable, that is a 10, that will be stored in that particular totally 16 bits, that is a 2 bytes. Then where this variable a will be stored? This variable a will be stored on something called as symbol table. So the processor, every time first it will be going on to the symbol table in order to get the information. So something like this. That is, the symbol table is going to consist of the variable name, the data type, and the starting address. So the processor first, it is going to come onto the symbol table and it is going to check there is a variable a and its data type. Its data type indicates how many bytes that it has to read on the RAM. For example, if it is an integer data type, it has to read totally 2 bytes of the memory. And it is going to even have the starting address, so that it will be knowing from which address it has to start reading that particular content. So here the variable a is being stored on the starting address is from 201. So from 201 to 202, the value of the 10 will be stored in the binary format. That is the reason why I have given here in terms of the binary format. That is a 10 and 1010, and the rest of the digits will be filled up with the zeros. That is, the rest of the bits will be filled up with the zeros. Okay, so for our convenience, even I have written A equals to 10 here. So similarly, even your B equals to 20, that is a binary format of the 20 will be stored. B will be not stored here, nor even like this decimal number 20 won't be stored. In fact, the binary value of the 20 will be stored, and the starting address and the data type, the complete information will be stored on the symbol table. Now there is a pointer variable is also there for us, that is a P in our program, where the P is occupying the starting addresses from the 208 and 209, and P equals to 201. Why I have written P equals to 201? That is, P is holding the address, that is the starting address of the A. So as we have seen here in the program, where we have written here P equals to ampersand A, where I am trying to store the address of the A into the P. So that is the reason why P is holding the starting address of the A. So P now holding the starting address of the A, that is nothing but the 201. Okay, now let us come back here. Now let us see this one, after storing the address of a particular variable into this particular pointer variable P. Now let us see certain printers in order to get more clarity about how we can manipulate the value of the A without using the variable A. We will be manipulating everything using the pointer variable P. That is something like this: printf percentile D, star P and star E. What is this star P? This A is clear, that is here it is going to print no guesses, that is it is going to print 10. But what it is going to print here? It is like this. Whenever it's a pointer variable, we are supposed to understand like this. I need to go to P, there I will be finding an address. I have to go to that particular address location and I have to pick up the value. I repeat once again. Whenever it is a pointer variable, I need to understand that I have to go to P. There I will be finding my address. I have to go to that particular address location in order to pick up the value. Now let us see the RAM. That is, I have to go to the P. There I will be finding my address. I have to go to that particular address location and I have to pick up the value. So the value here is the 10. So here what it is going to print? So here once again here also it is going to print the 10. That is, without using the variable A, we are picking the value of the A. So this concept is called as dereferencing. That is, we are not referencing a particular variable directly. In fact, we are dereferencing it. So it is called as dereferencing. Right. Now coming to this one. Now let us see this printf. Printf percentile U double quotes close comma P. When we will be using the percentile U, we know that percentile D, percentile F, percentile C, percentile S, these are called as format specifiers, and percentile U is also a format specifier whenever we wanted to print an address location, because we know that every address will be an unsigned one. There is a format specifier called as percentile U, which we will be generally using in order to represent an address location. Right. So printf percentile U P. So P, so it is pretty straightforward. That is whatever the P is holding. That is, P is holding the 201 as an address. 201 as an address, which is the starting address of the A. So here it is going to print 201. Now printf percentile U ampersand P. What is ampersand P? That is address of P. Just like ampersand A indicates the address of the A, similar way ampersand P indicates the address of that particular pointer variable. So here, what is the address of this particular pointer variable? That is a 208. So here it is going to print 208. 208. Okay, star P, value of the A, P, the value which has been held by the P pointer variable, ampersand P indicates the address where the particular pointer variable is located. Now let us see about this one now. Printf percentile U ampersand A. So ampersand A, just now we discussed, it is going to give you the address of the A, that is nothing but the 201 there. So address of the A is 201. Then what about this? Printf percentile d star a. So whenever it is star a, we know that like a is not a pointer variable. Now let us see like what if I am trying to do this one. That is just now we have learned whenever it is any star p or star a, I need to go to the a. There I will be finding an address. I have to go to that particular address location and I have to pick up the value. But see what's going to happen if I do that. I have to go to a. There I will be finding an address. What is this address? This is nothing but the 10. Okay, this is nothing but the 10. So I have to go to that particular address location. So whenever I will be going to that particular address location, obviously I will be going out of the memory that has been allocated to our program. That is, we are peeping into some another process. That is, here it is our operating system. So we are going out of that memory that has been allocated to our program. So this is not allowed dead. So and even like we don't know like where exactly that we are going to end up. So this is something like shooting in the dark. So it is never allowed it. So this is outruled. Never I can do this one. Okay, now let us see these 4 interesting printers. Now watch this one. This is quite interesting. Printf percentile u star ampersand p. So what is ampersand p? We know that is the address of the p. That is address of the p is nothing but the 208. Star indicates value at that particular address location. So the value at that particular address location is 201. So this is going to be 201. Right, coming to here, percentile u ampersand of star p. That is, we know whenever it is star p, I have to go to p, there I will be finding an address. I have to go to that particular address location. That is, I have to go to p, there I can find an address. I have to go to that particular address location and I want the address of that. That is nothing but the address of the A. So here once again it is going to print 201. Now let us see this one. Percentile u star of ampersand A. That is, ampersand A is nothing but the address of the A. Star indicate value at that particular address location. So the value at that particular address location is the 10. Is 10. Now let us see this one now. Printf percentile u ampersand of star A. That is, I have to go to A. There I will be finding one address. I have to go to that particular address location. So whenever I will be going to the A, I will be finding an address that is the 10. I have to go to that particular address location and I have to print the address there. But I am going out of the the memory that has been allocated to my program. So therefore, once again, this is also not possible. Okay, right. So these are the basics of the pointer. In our next video, we will discuss why that pointer variable has to store the address of a similar data type when all the pointers are of the same size.